when you have to move the decimal towards left, the exponent will be of a positive integer. So here the example is 2 into 10 power 3, that has to be multiplied with 3 into 10 power 4. After adding 4.5 and 2.5, you will arrive at the answer as 7.0 into 10 power 6. Accuracy means it is closeness to the actual or true value. That means how closer to the actual measurement. Good morning, dear students. I am Roja, your chemistry lecturer from Vidhyaashram PU College, Temple of Excellence. I hope you have understood the previous session, and let's recap once again. So, in the previous session, we had studied about importance and scope of chemistry, then matter and its classification based on both chemical properties and physical properties, then nature and their properties of matter, then SI unit. Shall we start today's session? Yes. Now, let us learn about scientific notation and how to represent scientific notation. Now, what do you mean by scientific notation? Say for example, mass of one hydrogen atom is equal to 0.00000 followed by 166 kg is given. Now, how to count the number of zeros? It is very difficult, isn't it? Now, similarly for Avogadro's number, it is 6020000 and it is very difficult to read now. Similarly, atomic radii is given 0.0000001 meter. For such numbers which are very large in numbers and which are very small in numbers, it is very difficult to read, write and operate. So, to simplify that, we have scientific notation which is represented by the formula n into 10 power n. Now, what is n? N is a number between 1 and 10. It can be 1.01 or 1.11 up to 9.99. This n is an integer both with positive and negative numbers. Alright. Now, how to represent the scientific notation using an example? Let us try that out. So, converting scientific notation. Now, how to convert given numbers to scientific notation? So, for example 1, the question is 6000000 and how do you represent with the scientific notation? See, when you have to move the decimal from left to right, the power will become negative. When you have to move the decimal from right to left, then the power will become positive integer. So, that is why when you move the decimal from here, you have to move the decimal from right to left. That is 1, 2, 3, 4, 5 and 6. So, we have moved 6 times. That is the reason it is 6 into 10 power 6. Similarly, we will try out this one. That is 897.566. See the decimal. Here after the decimal there are 3 digits and before the decimal, that is whole number has 3 numbers. Okay. Now you have to shift the decimal to the left side. Now how many times to shift the decimal? 1, 2. So it is 8.97566 into 10 power 2. So we have moved 2 times here. So it is 10 power 2. Here also we have moved 6 times to the left side. So it is 10 power 6. And both these powers will be in a positive integer because we have moved decimal to the left side. Now, we'll take example for the shifting of decimal to the right side, how it would be. Here is an example, 0.000045 is an example. Now, you have to shift the decimal. How many times? We'll calculate 1, 2, 3, 4 and 5. How many times? It is 5. But here, since we are moving it from left to right, the exponents should be in a negative value. So, it becomes 4.5 into 10 power minus 5. Clear? Now, for the second one, we'll shift the decimal point 1, 2, 3, 4, 5, 6 and 7. So, that is the reason 1.865 into 10 power minus 7. Let us try out these examples now. Here it is given 300. We have to bring it to scientific notation. Alright. So that is, we have to move the decimal point towards left side. 1 and 2. So it becomes 3.00 into 10 power 2. Here in the second one, decimal number is given. 3 zeros are there and followed by 6, 7. We'll see how many times to move. 1, 2, 3 and 4. So it becomes 6.7 into 10 power minus 4 because we have moved decimal from left to right side. Then C question, look at this question. It is having 89000000. So we'll try to count the numbers to shift the decimal towards left side. So 1, 2, 3, 4, 5, 6 and 7. So the answer becomes 8.9 into 10 power 7. Then for the last question, 1, 2 and 3. So I have shifted the decimal point 3 times to make a scientific notation, that is 7.2 into 10 power 3. So it is to be minus 3. So anything that you relate with the scientific notation, please remember the trick, that is when you have to move the decimal to the right, the exponent will be of a negative integer. When you have to move the decimal towards left, the exponent will be of a positive integer. I hope it's clear. Now here are some questions for you to try yourself and keep the answer ready. To verify your answer, watch this session until end. Okay. Now let us see operations based on the scientific notations. To simplify the scientific notation, we have to follow certain rules based on the operations. Now let us see multiplication and division and what is the rule to be followed. Alright. For the multiplication, the rule that you have to follow is multiply the numbers and then add the powers or the exponents. How is it done? Let us see through the example. So here the example is 2 into 10 power 3, that has to be multiplied with 3 into 10 power 4. Now you have to multiply the numbers and add the exponents. So it becomes 2 into 3 into 10 power 3 plus 4. So the exponents are added here. Then what is the final answer? 2 3s are 6 into 10 power 7. 3 plus 4 is 7. I hope you have understood. So we'll try the next question. Here 4 into 10 power 2 should be multiplied with 2 into 10 power 3. How do we do it? Is equal to, first multiply the numbers, that is 4 into 2. Then add the exponents. Keep the base same but add the exponents, that is 2 plus 3. Now 4 2s are 8, that is into 10 power 5. You got the answer, 8 into 10 power 5. Similarly, we'll try this question also. 6.5 into 2. These are the numbers that is to be multiplied first. 6.5 into 2 into 10 is the base. Then add the exponents, 5 plus 2. Okay. So 6.5 is 13.0 into 10 power 7 is the answer. Then we shall learn about division rule. What is the division rule is, divide the numbers, then subtract the powers. In multiplication, we used to add the exponents. Here we have to subtract the exponents. How do we do it? The question says 6 into 10 power 5 should be divided by 2 into 10 power 3. Then 6 and numbers to be divided first, that is 6 divided by 2 has to be done. As usual, the division rule. Then you have to apply that. Exponent should be subtracted. So this 3, when it goes to the numerator, changes its sign to the opposite sign. So that is 5 minus 3. Now 6 divided by 2 is 3. 10 to the power 5 minus 3 is 2. That is how you can solve. But we'll try some more examples. See, 8 into 10 power 6 divided by 2 into 10 power 3. How do we do it? So it is 8 divided by 2 into 10 to the power 6 minus 3. This 3 in the denominator has taken to the numerator. 8 divided by 2 is 4 into 10 power 3. 6 minus 3 is 3. That is how the result. Then we'll try some more example. Here, as you can observe, 9 into 10 power minus 4 and 3 into 10 power minus 6. Both are in the negative integer. So we'll try it out. 9 divided by 3 into 10 power minus 4. When this minus 6 in the denominator goes to the numerator, it changes its sign. So it becomes plus 6. That means minus 4 subtracted with minus 6. Minus 4 is kept as such. Minus into minus plus, then 6. That is how the exponent is written here. Now 9 divided by 3 is 3 into 10 power. You have to subtract because there are opposite sign. 6 minus 4 is 2, and so here greater number is 6 having a positive sign. So the answer will be in 3 into 10 power 2, positive integer. Clear? Now let's study about addition and subtraction. For the addition and subtraction, the same rule follows, that is, first make the powers of 10 equal first, then add or subtract the numbers based on the operations that is given, either add or subtract. So let's try that out with the examples. Here is an example of 4.5 into 10 power 6 should be added with 2.5 into 10 power 6. 4.5 plus 2.5 into 10 power 6, that is common, has been taken out. Then after adding 4.5 and 2.5, you will arrive at the answer as 7.0 into 10 power 6. Here in the addition, you have to take the common base with the common exponent. Let's try the other example here. Here 3.0 into 10 power 5 should be added to 4.2 into 10 power 4. See, here you can observe it is different exponents, 10 power 5 and 10 power 4. Now what does rule say? Rule says that make the powers of 10 equal first. Either you can change this power or this power, that is up to you. Now suppose I'll change this power to make it equal to 10 power 5. How do I do it? Say the given number is 4.2 into 10 power 4. Now I have to increase the number, exponent number. So how do I do it? I said shifting the decimal towards left side gives the positive integer. Correct. So now I am going to shift this decimal towards left side to make it 5. So what happens? It becomes 0.42 into 10 power 5. Okay, now we shall add it. 3.0 plus 0.42 into 10 power 5. Now after adding, it is 3.42 into 10 power 5. Clear? When the powers are different, you have to make it equal by shifting the decimal. Either of it can be shifted to make the powers equal first. Now we shall see how to subtract based on the rule. So the rule says again, make the powers equal first. So here you can observe it is 10 power 6 here, 10 power 5. Now I'll consider this 5.0 into 10 power 6 and convert it to 10 power 5 to make it equal to this number. So it is 50.0 into 10 power 5. Now that is, I am shifting the decimal towards the right side. Now upon subtracting 50.0 minus 2.0, you will get 48.0 into 10 power 5. Now if I have to keep it in a single digit, so it becomes 4.8 into 10 power 6. That means I am shifting this decimal towards left side. So the exponent has increased to 10 power 6. Either you can change this one or this one. Now here are the few questions for yourself to try it out, and you'll get the answer at the end of the session. Okay. Now let us move to the next topic, accuracy and precision. What do you mean by accuracy and precision? Accuracy means it is closeness to the actual or true value. That means how closer to the actual measurement. And the precision is it is closeness between the repeated measurement. That means how consistent or repeatable the measurements are. How do we understand? We'll explain it with the example of bull's eye. I hope you know how to play bull's eye. There is a target at the center. That is wherein you have to hit the target. So that target, hitting the target, here let us assume hitting the target is equal to the accuracy. So that is the accurate value supposed to be done here in the bull's eye. And the precision value is how repeatably or how consistently it has hit the same target or at the same place, you can say. Here in this first example, now the target is at the center. There are 4 shots, you can observe 1, 2, 3, 4, and all the 4 shots are hit the target. So when these all 4 shots are hit the target, that means the measurement is true to be accurate. Then here when it comes to the second one, the target is at the center, but all 4 shots are hit somewhere away from the center, and most of the 4 shots are hit at the same place. Repeatedly, consistently, the shots are hit at the same place, so that it can be said as it is not accurate but precised. Precised in the sense consistent shots here. Now with the third example, all the shots are scattered away from the target. So this can be said as it is not even accurate, not even precise value. Now coming to the fourth example, here also all 4 shots are scattered away. They are not even precision, they are not even accurate value. I hope you have understood. Or let us see the other example. Let's say you are weighing about 5.00 grams of a substance. Okay, so that 5.00 gram is said to be the actual value that is to be weighed. Now there are 3 students who are going to take 3 trials. We'll see what are the measurements they have got. So for the student A, from trial 1 and trial 2 and trial 3, he has arrived at 5.01 grams, 4.99 grams and 5.00 gram. So these values shows that it is true to the or closeness to the actual value. So it can be said as accurate. And since he within all these 3 trials, he has arrived at the accurate value. So that can also be called as precise value. Every time when he did, so he has arrived at nearer to that value. So that can be called as precise value. Now coming to student B, on the first trial he has got 4.52, and the second 4.53, and the third trial is 4.51 grams. But 4.51 is not the actual value that he has to get. The actual value is 5.00 gram. Here it is not accurate with the values that he has arrived with, but you can say that it is only precise value. Why? Because upon the 3 trials, he has arrived with the similar values but not actual value. Coming to student C, on the first trial he has got 5 grams, 5.00 grams, and the second trial 4.98 grams, and for the third trial 5.02 grams. Here, upon observing, he has got average of accurate value, not exactly but moderately, but this cannot be called as precise value because there is a difference here. 4.98 gram is not nearer to 5.00 grams. So through this we can understand about what is the difference between accuracy and precision. Say for example 5, 5.0, 5.00. Is there any difference between 5, 5.0 and 5.00? seems to be same number, but these numbers have different levels of precision. So, significant figures reflect the accuracy of measurement and not just number. Also, it indicates the reliability of a measurement. Now, significant figures are the digits in a number that show how precise a measurement is. Now, to understand that, you should know certain terms that is used here in the significant figures. So, here is a number with 0.000670800. Now, there are certain terms that you have to understand, that zeros that is written behind the non-zero digit or that comes in the beginning of a number is said to be known as leading zeros, and these 6, 7 and 8 are known to be non-zero digits, and this 0 in the middle is a 0 which is sandwiched between two non-zero digits, and zeros at the end are known to be trailing zeros. So, there are 4 terms that you have to remember: leading zeros, non-zero digits, and 0 that is sandwiched between non-zero digits, and the trailing zeros. Now, how do you represent significant figures? There are certain rules that you have to follow. Now, leading zeros are not significant. They are not said to be significant, and all non-zero digits in a number are said to be significant. Then 0 in between non-zero digits are said to be significant. Then trailing 0 with decimal, that is decimal is given here, is said to be a significant. Now, how to indicate the significant figures? We'll try with the examples having that same rule. Okay. Now, the first question is 0.0025. I've said the rule is that leading zeros are not significant. Now, count how many significant figures are there here. 1 and 2. So, there are 2 significant figures in this number. Then 208. I said the rule is 0 that is sandwiched between 2 non-zero digits are also counted, and non-zero digits are 2 and 8. So, how many significant figures are there? 1, 2 and 3. Alright. So, next number is 5005. So, there is no decimal, but zeros are in between 2 non-zero digits. So, all 4 is to be counted. 1, 2, 3, 4. So, there are 4 significant figures in this number. Now, the next number is 126000. That means trailing 0 with decimal are significant, but here there is no decimal. So, trailing 0 without decimal is not significant. You have to consider only non-zero digits, that is 1, 2 and 6. So, there are 3 significant figures. Here in this example, these 3 zeros are trailing 0, but there is a decimal. So, all 3 zeros are to be counted. So, it is 500.0, and how many significant figures are there here? 1, 2, 3 and 4. Now, 2.0034 is there. So, zeros are in between the non-zero digits. So, 1, 2, 3, 4, 5. There are 5 significant figures. Now, 3.5 into 10 power 3. How do you do this? The number behind the exponential form will be considered as significant, provided you have to follow the rules. So, here it is only 3.5. So, non-zero digits are significant. Only you have to count these numbers. So, there are 2 significant figures. Now, let us understand the operation on significant figures. So, first we will see addition and subtraction. How do we do that? There is a rule like round the result to the least number of decimal places among the numbers. What do you mean by that? We will try with the example. There are 3 numbers to be added, that is 12.11, 18.0 and 1.013. So, you have to check here in the rule that is given, you have to find the least number of decimal places among the numbers. So here in the first one, there are 2 decimal places. Here in the second number, there is only 1 decimal place. And here in the third number, there is only 3 decimal place. So the least decimal place is 18.0. Now after addition, the answer is 31.123. So final answer, what do we do with the final answer is round the result to the least decimal value. So the actual answer that we have got is having 3 decimal values, correct? Now that we have to reduce it to 1 decimal value. So the answer becomes 31.1. You can discard this 2 and 3 and bring the result to the 31.1. Similar rule applies for the subtraction also. Next we'll move to multiplication and division. Round the result to the least number of significant figures. For the addition and subtraction, you have to check for the decimal place value. Here you have to check for the least number of significant figures. So we'll try it out. 4.56 should be multiplied with 1.4. Now 4.56 has 3 significant figures and 1.4 has 2 significant figures. Which is least among these two is 1.4. So you have to report the result to the least significant value, that is 2. Then after multiplication, you will get 6.384. So what is the least significant value is 2. Now you have to discard this 4 and the answer will be 6.38. This 6.3 has to be rounded off. After rounding it off, you will arrive at the answer of 6.4. Now how to round off the numbers, that we'll see in the next. Here is a memory trick for you all to remember how to operate on significant figures. So remember, when you add or subtract, you have to check for the least decimal places. For the multiplication and division, you have to check for the least significant figures. Now, how to round off the significant figures? So there are certain rules that you have to follow. With the example, we'll see through how to round off the numbers. So first rule is, if the digit is to be removed is greater than 5, if the digit to be removed is greater than 5, increase the preceding digit by 1. That means you have to add 1 to the preceding digit. Here in the example 1.386, 6 is greater than 5. So that has to be removed here and the preceding digit is 8. So what does rule say? You have to increase the preceding digit by 1. Upon adding 1 to this 8, the answer becomes 1.39. If the digit to be removed is less than 5, keep the previous digit. So you're not going to change the preceding digit, you have to retain as such. So in the example 4.34, this 4 is less than 5 and the preceding digit is 3. So retain the preceding digit as such and the result is 4.3. Now if the digit to be removed is 5, again there are 2 criteria. If the previous digit is even, you don't have to change the previous digit, you have to retain as such. For example, 6.785, the last digit is 5, that is to be removed, and the preceding digit is 8, which is even. So you don't have to change anything here. So the answer becomes 6.78. If the previous digit is odd, increase the preceding digit by 1. That means you have to make it even. For example, 7.435. So this is the last digit with 5. Then the preceding digit is 3, which is odd number. You have to make it even by adding plus 1 to this 3. So the answer becomes 7.44. As I told earlier, the answers will be given in the end of the session. Now try whether your answer is correct or wrong. So first, as per the scientific notation, you know how to represent scientific notation, that is n into 10 power n. Okay. Now first question, it is 0.0048. So you should remember the trick. What is that trick? So as in when you shift the decimal towards the right side, the exponent will be negative integer. As in when you move the decimal point towards the left side, the exponent will be positive integer. So I'll move How many times we'll check? 1, 2 and 3. So the answer becomes 4.8 into 10 power 3. Since I've shifted this decimal towards right side, the exponent becomes minus 3. Now for the second one, I have to move the decimal towards left side. 1, 2, 3, 4 and 5. So I have moved 5 times. So the answer becomes 2.34 into 10 power 5. It will be in a positive. So for the third one, 8008, the answer will become, so I'm going to move the decimal from right to left, 1, 2 and 3. So 3 times, the answer becomes 8.008 into 10 power 3. So the exponent will be positive integer. Now here it is a decimal point and then we'll try to move towards left side. So 1 and 2. So 2 times when I shift the decimal, the answer becomes 5.00 into 10 power 2 because I've moved 2 times. Here in this question 60012, the decimal is moved towards left side 1, 2, 3 and 4 times. So the answer becomes 6.0012 into 10 power 4. I hope the answers are matched and check whether your answer is correct. So we'll try these questions, addition and subtraction based on scientific notation. So I hope you remember the formula for the scientific notation, how to solve about. Then here the powers are different. You have to make the powers equal first. Okay. So I'll try to make this power equal. Now if I have to move the decimal towards right side, it is negative integer. Towards left side is positive integer. Now I have to increase the power. So I'll have to move towards left side. So this 3.0 into 10 power minus 23 becomes 0.30 into 10 power minus 22. Now the bases are same, so that you can add easily. 2.5 plus 0.30 into 10 power minus 22. So the answer is 2.80 into 10 power minus 22. I hope the answer is correct. So we'll try the second one. That is 41.7 into 10 power minus 27 minus 2.1 into 10 power minus 26. So the exponents are different. We have to make it equal. So I'll take up this number, that is 2.1 into 10 power minus 26. Now that I have to bring it to minus 10 power 27. So upon shifting, it becomes 0.21 into 10 power minus 27. So that I've shifted the decimal towards left side. So the exponent is minus 27. Now we'll try to solve it. 41.7 minus 0.21 into 10 power minus 27. So the answer is 41.49 into 10 power minus 27. So this is the answer. Please check your answer whether it is correct or wrong. I hope you have understood the session. And in the next session, we'll meet you with laws of chemical combination and Dalton's atomic theory. Thank you.